Hi, I'm Bill. In this video, I'm going to take you through my project, which is a gamified version of the beep test. The beep test is this really boring fitness test that we have to do at school, involving running between two lines in time with beeps that slowly get faster. I thought that if I make the regular boring beep test more fun, then maybe people would do better. So this is my beep test fully set up. It's got sensors at each line to tell my code when the line's been crossed, and LEDs all up the side of the course to give the user an idea of how well they're doing. So, as you might have heard, it was saying, please proceed to the red starting gate, which indicated in red here is this line. So I'm just going to cross it, and it'll give me a countdown until when I have to start. And so, when it does start, I'll run to the next line and be right back. To the next beep. If I cross the line in time, it'll turn green and I'll be right back. If you don't make it in time, the line will turn red. And eventually the beeps just get faster and faster until you can't keep up. And then by the time it ends, it'll tell you your score and give you a bit of encouragement, like you're about to hear.
Good job. You made it to level 5.
And so it said, good job, you made it to level 5. And so now I'm going to show you some clips of some actual people doing it for real and at full speed.
It's cheating!
So now that you've seen my beep test going, I'm going to show you how it works. So inside this cat cage here, I've got most of my electronics, and I've taken out the main ones for you to see. And so here I've got a computer CPU or a computer stick, which my dad ordered online. But it's only got 2 USB ports and no audio socket. So I've plugged in a USB hub here with a USB to audio adapter. And so now I'm going to talk to you about these other 2 things plugged into the hub. So inside this black box here, I've got a Nusbio Pixel, which allows me to control each individual LED at each end. I've also got a Nusbio, which allows me to monitor 8 individual GPIO pins, but I'm only using 2, one for each sensor at each end, so my code knows when the runner's crossed the line. I've also got a step up, which steps up the voltage from the 12 volts coming into the box to the 24 that my sensors need. I got my LED strips from AliExpress, and I've got 150 LEDs in each. So now I'm going to talk to you about my sensors, how they work, and where I got the components from. So here we are at one of the ends. I've just got a standard infrared beam sensor, like you'd see in the dairy, where they have a beam across the door, and when you cross it, it makes a sound so the dairy owner knows that you're there. But except mine's slightly different. Instead of having one beam, it actually has 2, because it bounces the original beam off these 2 mirrors and into the retroreflector and back. So there's actually 2 lines your foot can cross. Because if there was just one beam, your foot could come up short or too long and it wouldn't register the lines being crossed. But with 2, there's a much bigger surface area for your foot to fall on. Like I'll show you. See, if I put my hand here, the red light will come on to show me that the line's been crossed. But also if I put my hand here, it'll also come on to show me the line's been crossed.
So now I'm going to show you some of the code which runs the game. I'll start off by showing you how I accessed the Nusbio. This was the device I used to observe the 2 pins connected to the IR sensor at each end, which detect when a line's been crossed. So this is just some test code that sets the pin mode to input and then reads it using one of the provided functions, and then displays it on screen. But I'll show you some of the code where I actually use it, which is this function here that my code calls to ask is the line crossed, and if it is crossed and the pin's high, it will return true. If it isn't crossed and the pin's low, it will return false. And so moving on to the Newsbio pixel, there's just two main functions I use. One is set strip, which just sets the whole strip to any color, and one is set pixel, which just sets any individual pixel. And so this bit of code here, it's looping around, waiting 10 milliseconds each time, and setting each individual pixel hot pink as you do, until the whole strip's filled, and then it flashes blue a few times. I could also set the brightness, and to set it up, it's pretty easy. I just create a variable and populate it with the Newsbio pixel using one of its functions. And so now I'm going to take you through some of my high level code and how it's organized. And so in here, I just have a base effect class, but inheriting from that is the two different classes sound effect and light effect. And then inheriting from light effect, just to be a bit more specific, is set LED range light effect. And having all this inheritance means that I can have a list of effects, but they can all be either a sound effect or a light effect. And so I can have all my effects just in one list. And they've all got, since it was on the effect class, two properties, which everything below effect inherit. And so the two properties are offset and what the offset's relative to. And using these two properties, my code figures out when all the effects need to be played and orders them in a list, and then works its way through doing each one when they need to be done. And so now I'll take you through how I made my music. And so I did that using Audacity, which is just some free software. And so first I just got a few workout mixes off YouTube and put them in here, and then I chopped out the good bits, like the bits with harmonies and stuff like that. And then I put the slow ones at the start, like this, quite slow, and working my way up to the fast ones like this at the end. And so now that you've seen my beep test going and how it works, I'll show you the results of the testing I did on some of my class using my invention. They each ran 3 times. The first time was the regular boring beep test as my control. The second time was with encouragement from friends. And the third time was with the Gamified version, which you've seen just before. And so basically I was trying to find out what really improves their score most over the control. Old-fashioned encouragement from friends or Gamified with lights and music. But the order they did those last two was randomized. And so on screen here are just the individual results of each person who did my test. Blue is the control, red is with encouragement from friends, and green is the Gamified version. And so as you can see, pretty much everyone did better than their encouragement from friends run and their Gamified run than their control. But this is where something really stood out. These graphs show the average improvements over the control for the 6 boys that did my test and the 2 girls that did my test. And so the red bars show the average improvement over the control with encouragement from friends, and the green bars show the average improvement over the control running my Gamified version. And so, as you can see, overall the girls made a significant amount more improvement in both scenarios, the encouragement from friends scenario and the Gamified scenario, with their most being 26%. And so, overall, I believe that girls may respond more than boys to external encouragement. However, I can't quite confirm these statistics as I only had 2 girls in my study, which isn't enough to have a reliable result. So that's pretty much it. I hope you enjoyed checking out my project. I'm sorry for the sniffing and heavy breathing during the code. I got a cold halfway through filming this video. Thanks to my neighbours who did some of my early testing, to my classmates who helped me gather that data we just went through, and to the football team at the Eco Centre who saw running my Gamified beep test.